so far? Anybody know?
That was our fourth one.
That was our fourth one? Okay, sweet. So we'll wait a little while longer before I collect all of them, but those are what we have so far. Okay, so now we are going to continue talking about, oh, I think Amani's coming in. There we go. Okay, so we're going to talk about ambiguous case triangles today. So these notes should be up on Canvas. If you don't have a printer, that's totally fine. Just follow along on notebook paper. Try to sketch out everything as best you can. Okay. So, and we're going to be using some colors, not a ton, but like at least 2 or 3 different colors. So have a highlighter or 2 on hand. Okay, so this says, so the ambiguous, oh my goodness, the ambiguous case is going to occur when we either have side-side angle or angle side-side with an acute, which means less than 90, okay, degrees, angle, all right? So remember that with our sine and cosine rule, we use basically all of the other triangle orientations. These are the ones that like don't work, right? These are the ones that we avoid using normally, and they're the inappropriate ones. This is the ambiguous case triangle. We have ASS or SSA, and the angle is acute. Okay, so it says the figure below shows an example of the ambiguous case triangle where C is 10. So I think it means, hold on, well, A is 6 and the angle A is 30 degrees. So we know this angle A is 30 degrees. Oh, you know what? I was going to show you guys a little demo. So basically the ambiguous case is when we have an angle measurement and 2 side measurements, or 2 side measurements and then an angle measurement. This angle is acute, and basically there are 2 possible triangles that can occur. Okay, so I was going to show you this on Desmos, or what was it? Might have been GeoGebra. Let me see if I can pull it up real quick, because that would be fun to do. Sorry about this. We might also just skip it for now, and then maybe if we have time at the end, we're going to do that. We're going to skip it for now, and if we have time at the end, I'll go do it. I'm sorry. Okay, so there are 2 possible triangles that can occur, and now is when I'm going to pull out my highlighter. I want these guys. Okay, so the first triangle I can create is this guy right here. And the other possible triangle is the big outer one, okay? Both of them have to include the angle that's given, okay? So I can't pick this triangle. I have to pick the one on the outside because I want them both to have that 30-degree angle in there, okay? All right, our side A was 6. So we know that this and this are going to be equal, and they're both going to be 6 centimeters. Okay, both of these are the possible side A's. Okay, because they're across from angle A. And it says C is 10, but it doesn't specify. Oh, I guess that would be this guy right here. All right, so C is the side across from the angle C. Okay, so 10 centimeters should be right there. Okay, and then we have 2 possible B sides. We could have from A to C1 or from A to C2. Okay, so there's 2 ways that can go. And there's 2 different angles that happen here. This angle could be different than that angle. Okay. and same here. All right, so our two possible triangles are going to look like this. Okay, where we have C1, A, B, and this is 10, this is 6, and this is 30. Okay, this was our pink triangle. And then our other example or possible triangle was this guy where we have A, C2, and B. This is 30. And then, let's see, this is 6, and then this is 10. That's our other possible triangle. Okay, questions so far? Okay, in one possible example, we have the C angle being obtuse. And in the other example, we have an acute angle. Okay, questions on that little introduction of ambiguous case triangles? Do you guys need a minute to copy this down?
Yeah.
Okay. Okay, so when we're solving for, so like if they asked us to solve these triangles, we have two different triangles and we have two different ways we need to solve them, okay? So the first possible way is using the sine rule, okay? The sine rule will only let you find the acute angle, so we're only going to be able to do this one with the sine rule, okay? And they use supplementary angles to set up the second triangle. Okay, so for the green triangle, we're going to set up our sine rule. We're going to use A over sine A equals C over sine C. Okay, because those are the values we know. Okay, and this is going to be solving for our C2 specifically. Okay, does everybody see that? What questions do you guys have so far? I'm going to make this smaller. I have a feeling I'm going to run out of room if I don't. We had little a, sine A, we'll see over sine, specifically C2. So using the acute angle. Okay, so now I'm going to fill in my numbers. 6 over the sine of 30 is going to be equal to 10 over the sine of C2. Okay, and our goal here is to solve for the sine of C, or to solve for C2. So I could cross multiply and I would get 6 sine of C2 equals 10 sine of 30. Divide by 6 on both sides. And I would get that the sine of C2, or that, I guess I'm going to skip a step so I fit it all, that C2 is equal to the sine inverse of 10 sine 30 over 60. Okay. That was really ugly. Looks like 3 degrees instead of 30. Okay, so sine inverse of 10 sine 30 over 60. So looks bad. Okay, and when you stick this in your calculator, you should get about 56.4 degrees is our C2. Okay, so what questions do you guys have so far?
I'm actually lost.
Okay, so where do you last understand what we were doing?
With 60 over sine 30, I just don't remember what you did after that.
Here, so this is where you last understand? Okay,
Yes.
so here what I did is cross multiply, so I have 6 times sine C2 equals 10 times sine 30. So that's where I got this. And then I went ahead and divided by 6 on both sides to isolate the sine C2. And then I kind of skipped a step. I could have written out that sine of C2 is equal to 10 sine 30 over 6. I just skipped it and took the arc sine of each side right off the bat. Does that make sense?
Yes.
Okay, are you unlost now?
A little bit, or more so.
Okay, okay. Okay, so now we have to use supplementary angles to set up the second triangle. So one fun property is going to be that angle C1 plus angle C2 are supplementary, which means they add to 180. Okay, so I can solve for angle C1. That's going to be 180 minus 56.4. Okay, which is going to equal 123.6 degrees. Oh, my degree sign got real big. Okay. But I'm not quite done yet because I still need to find like little b1 and little b2, those side lengths. So now at this point, at this point I have, or I could have all of my angle values because I have my A and my C, and triangles have angles that add to 180. So I could find the angle B, okay? But I don't really have a clue what the side B1 and the side B2 are. And that's where the cosine rule is going to come in. So are there questions before we start that section of the notes? Caroline, you good? Yeah. Okay. Okay, so now, so if I wanted to find B1 and B2, I would need to set up an equation, okay? I don't happen to have, unless I sat down and solved for the angles B1 and B2, I don't have them, so I shouldn't use the cosine rule where I have like B equals A, or B squared equals A squared plus C squared. I want to use one that has B in it, but uses an angle that we have already. So I'm going to use A squared equals B squared plus C squared minus 2BC cosine of A. So this has little b in it. We can solve for little b still. Okay. And we have side A and we have angle